Welcome to another video to learn AP Statistics. This is our second video in AP Statistics playlist. And in the last video, we introduced AP Statistics and we introduced how to draw Stemplot, also the categorical and quantitative data, like variables also. And in this video, we're gonna starting by drawing a Stemplot together for the question that we introduced in the last video. So if you remember that we're asking to draw a Stemplot of the ACT data that has been collected for the AP Stats math scores. So in here we're given two tables, each one has scores and their corresponding frequencies, which is also a frequency table. So first of all, think about Stemplot as two parts. The first part is the stem part, which think about it as main part of the tree, and the second part is the leaves. So think about it like there's a bunch of leaves in one tree, right? Which means that the one root of the stem. One root of a Stemplot can have many leaves, and it can have a lot of digits, all belongs to one root. So I'll show you first draw that as a T-chart, so like that. And in our situation, there's only three starting numbers, which is 1, 2, and 3. But it does not have to be starting with 1 and end with 3. It can start with 1 and end with 9. It all depends on the situation, but in our question, there's only numbers that are starting with 1, which is like 17, 18, 19, and also numbers starting with 2, 20, 22, 23, etc., and numbers starting with 3, which is only 30 and 32. So for this question, it's kind of nice. It's already given us in order, so we don't have to organize it by ourselves. But in a lot of the cases, we have to do it by ourselves. First put all the data in the correct order, either ascending order or descending order. It's fine, but it has to be in order. But in this case, we don't have to care about it. So we will first after we put down the root numbers for each Stemplot's digit, we will put their corresponding leaves to each root. So say that 1, 7, there's a slash in between, it means that 17 in here, and 1/8 is 18, and it goes on like that. And don't forget that the key part for the Stemplot is to put down the key in here. So key is what you told the reader that what does my Stemplot means. I draw it in this way, and what does 2/0 means? Well, it means 20, and this is an example for it. Okay, so this is a Stemplot. And so there's another example for it, which we can split stem in here. So 1, 1, 2, 2, 3, 3, 3, and there's also a key for it. So there's a lot of ways to draw a Stemplot. It all depends on how you think about it. So, but the key components is to draw the T-chart first. Be sure to label the stem in here. I didn't label it, but you should on the test. And in here, there's this column should be the stem, and this column should be the leaves. Okay, so let's move on. In the last video, we introduced on how to describe the distribution, but we haven't go further for that. And so we will go a little bit in depth in this video, which I will be asking you, how do we describe this distribution? Use your socks. Well, what is socks? Socks, it stands for 4 words: shape, outliers, center, and spread. And so you put the capitals together, it becomes socks. So what does each word means? So shape usually it means that how is your like what is your distribution look like in the first look. So it can be like it can be symmetry or skew right or skew left, and it all depends on your first look. And there's a lot of different shapes. Also, it can also be uniform or other things, which we'll talk about later. Outliers is generally meaning that the data that is out of the main trend of a distribution, which I will go in depth like later in the video. And the center, this is where the mean or the median lies on. And the spread is basically the standard deviation, but sometimes it can also be in range. Like range is the maximum minus the minimum. So I'll go deeper later, pretty soon. Okay, so let's first talk about the shape. So shape, the definition for it is there are 3 basic shapes to recognize, and the first one is symmetric, and it means right and left sides of a histogram are mirror images. So it means that if you draw like axes, like in between the distribution in here, the left side and right side are approximately equal. Like no one can guarantee they're like completely equal. That's kind of rare in real life. But if they're approximately equal, like there's no kind of like a lot of amounts of data in here compares to here, then we can say that the shape is symmetric. And same for this. Take a look at this. This is also symmetric because if you draw a line in between this data, the left side and the right side can also have approximate equal amounts of data. So don't just think about symmetric in one shape. It can be a lot of shapes. Actually, in the first graph, this is a bell curve also, and it's also like only one model in here, which in the second graph, this is bimodal. So what are some like real life examples for symmetric shape? Well, there is some temperatures and SAT scores, like IQ levels and some gas prices. So think about it like symmetric is where it's kind of like the whole graph is approximately normal, and and like most of the data are lying in like the range, and another set of data is also like another range, which is kind of like distributed nicely. So think about symmetric, like really think about it. I think there's gonna be no problems for that. So let's move on to the next type of graph, which is skewed right. This means that there is a tail on the right side of the distribution. So take a look at here. This is like a little tail in here, and this is on the left side. So this is kind of like getting harder, like a little bit confusing. A lot of beginners will think that the whole graph, it kind of like most amount of data are lie in the left side, so this is going to be a skewed left graph. Well, that's not the case because you don't look at the head of a graph, you only look at the tail. So if the tail lies on right, then this whole graph is skewed to the right. And there are some real life examples are like average income or wages, lifespan, and gas prices, and really hard test. Yeah, so I think the last one maybe related the most, because if your teacher gives you a very hard test, and the whole class, there's only like a really few people, like just a couple who scores high, then like the like the bars, the little bars in here is going to be very low, where most of the people like didn't score high enough, then the majority of the people will lie in the left of the graph. So that's a skew right shape. And the skew left shape, which you probably can imagine, is the opposite of the skew right shape. So this means that there is a tail on the left side of the distribution. So right here, this is the tail and it's on the left. And some real life examples are like the health issues, inflation of years, population over years, and age at first marriage. Yeah, like those examples are not like pretty accurate. It maybe varies a little bit like year from year, but most of the times we won't consider it to be normal or skew right. So I put them in here just for reference. Yeah, so this is skew left, which is kind of opposite with the skew right. Okay, so this is what I talked previously, the uniform graph, which is different with others. You can see pretty clearly. Uniform graph, you can see that it's basically like all of the bars are on the same horizontal line, which is kind of weird. I mean, when I was first learning it, I thought it was like kind of really weird. But uniform graphs, it basically means that like every individual's like whatever like their performance are kind of like equally spread out. So some real life examples are like date versus the number of breaths, and the date versus the number of days of rain, and some like when you're rolling die. Like so when you're rolling die, like the last example I think is pretty good because we all know there's like 6 sides in one die, and the 6 sides all have the equal chance have been rolled. So that's where that's what the situation that creates a uniform shape graph. Okay, let's move on. So this is a histogram, which I think I will talk about it more in the future videos. But histogram, I can do a brief introduction in here. It means like a histogram has the quantitative variable on the x-axis and the frequency on the y-axis. So like some of the examples are like SAT data, and here's we also given a frequency table, but I think I will talk about it more in the future videos. So yeah, in this video, I just want you to focus on the different shape of distribution, and remember the when you're describing a distribution, you always have to mention these 4 components: shape, outlier, center, and spread. SOX, remember it. And we also practice to draw the Stemplot. Okay, so I think that's enough for this video, and more content, stay tuned, and I hope you learned something from this video. Thank you so much for watching.